Hi all, Miss Ross here, and we are today covering Unit 2, Day 3 on linear measure, and this is part 1 of 2 parts. And we're going to be talking about line segments, segment addition postulate, and congruence statements. So first of all, a line segment we are going to define as part of a line. So part of a line that is bounded, by 2 distinct endpoints. So notice that this is not a full line. Like if we were to consider a full line is infinitely bounded. So a line segment, it's as if we're cutting it off or we're truncating it, and it will be endpoints such as A and B that cut it off. Line segment measure is when we actually assign a unit of measurement to a line segment. So if I were to look at this scenario here, maybe I take a ruler to line segment MN and I want to measure its true length. So this is where you're giving a true unit of measurement. So we'll say that we assign unit of measurement to a line segment. And a word of caution here is that not all line segments will be drawn to scale. So if I were truly measuring line segments on a piece of paper, whether I'm in the metric system or just working with inches or so forth, then it would have a particular length or magnitude, but not all drawings are drawn to scale. So more often than not, when we are talking about a line segment, it's just working with the concept of the line segment and not its particular measurement. So we just want to be on the lookout for if it is defining measurement, then it's assigning a unit of measurement to that length. Segment addition postulate is what we are going to be working with a lot in the next couple of days. And segment addition postulate allows us to break up a full line segment, such as this guy here, AC, into 2 separate segments. So we have segment AB, and then we have segment BC. And the segment addition postulate tells me that the parts sum to make the whole. So in this case, segment AB plus segment BC equals the full line segment AC. And we will be using this a lot in geometry. Again, the sum of AB plus the BC line segment together makes the entire line segment AC. This is what this one says. So we're going to be using this in a series of examples when we're being asked to write the segment addition postulate for each example, and then write an equation to solve for the missing piece, and we're going to actually be finding the indicated value. So we have some algebra mixed into our geometry concepts here. Okay, so first of all, let's write our segment addition postulate. So for scenario 1 here, we want to notice that we have part AB and part BC that together make the full AC. So I'm going to go ahead and write AB plus BC equals AC. So that's telling me that line segment AB plus line segment BC equals line segment AC. Now notice that if we were to use the proper grammar here, we actually should have a line on top. That's the appropriate way to express a line segment. But for the sake of calculation, whether you're writing that in there or not is not a concern. Okay, so now that we have our structure here, we are also being asked to write an equation to solve for the missing piece. So in this case, notice that we are being asked to find AC. So if I want to find AC, my equation is already written in such a way that AC is isolated. So when I want to find the indicated value, we are going to now substitute. So they're giving us AB to be 3, and BC is 11, and I'm solving for AC. So if I just simplify my expression here, I would have 14 equal to line segment AC. So the length of the full segment AC here is the sum of the two parts, 3 and 11. And then we have it for number 1 here. A is asking us to find DF. If we know that EF is 4.5, so we have this line segment here, and ED is 0.9. Notice that we can switch the order of the letters here, and it's still going to be referring to the same line segment. So if we know that line segment ED is 0.09 or 0.9 inches, and EF is 4.5 inches, we want to find the entire length DF. So let's first write our segment addition postulate. So in this case here, we have DE plus EF equals DF. Notice that they did switch around the order, like we mentioned, of E and D here. So if we even wanted to change that right now, just to make our life a little bit easier, ED plus EF equals DF. But notice that when I change them around, it's not as clear that they're summing to DF. So sometimes it just is preferred to, read it from left to right. Okay, when I'm writing an equation to solve for the missing piece, the missing piece here is DF. So we've already written our equations so that DF is by itself. So now let's go ahead and substitute our values in. We know that ED is 0.9, so I'm substituting for 0.9, and EF is 4.5. So here I am substituting my values in, and I know that I'm going to be adding the two to find segment DF. So if I add these two together, I will end up with 5.4 equals DF. And since we're working with inches, this is truly 5.4 inches. So that is the length of DF according to my segment addition postulate. Okay, now let's look at finding YZ. So here, this one's a little bit different because they are giving us the full length and a partial length, and we want to find the other partial length. So if we write our segment addition postulate for this case here, let's just change up the colors. Notice that we have XY plus YZ equals the full length, which is XZ. In identifying that we want to find YZ, let's rearrange the segment addition postulate so that YZ is by itself. And that's going to require that I subtract XY from both sides. Unlike algebra, this is not the product between x and y. This is just the name of a line segment, right? So I'm really just moving the whole entity. But this is telling me that line segment YZ equals segment XZ minus XY. And now I've rearranged it so that I can solve for YZ. And that means I need to substitute my values in. So line segment XZ is given to me as 32, right? This is the full length right here. Line segment XY, this little guy here, is 15. So I'm just taking 32 minus 15. If I subtract the two, 32 minus 15, I will get YZ equals 17. And notice that we'll work with millimeters because that was what was given to us. All right, so sometimes we do have to rearrange for our line segment of interest. Next, let's look at this case with G, H, and K. And we're just going to jump right into our segment postulate. Remember saying that the sum of the parts makes the whole. So GH plus HK equals the full length, which is GK. Identifying what it is we're looking for, should actually say, well, find. We're going to change this. They're giving us GK, they're giving us the full length, and they're giving us HK. So that means that we're missing GF, or GH. So let's go ahead and change this to find GH. Okay, so if I know I want to find GH, I need to rearrange my equation so that GH is isolated. So for this to happen, I need to subtract my HK from both sides. These cancel, and I will have GH equals GK minus HK. And now I've rearranged it so that I can substitute my values in. I'm looking for GH, and they're telling me that GK is 75, right? This is the full length of this line segment, 75 millimeters. And HK is given to me as 0.9 inches. Wow, we have a mix of units of measurement here too. I think that was a typo. I don't think we meant to have that happening. Let's change this to millimeters. So we're just going to go ahead and subtract 0.9. And if I go ahead and subtract the two, I find that GH equals 74.1 millimeters. So notice that's definitely not to scale. I don't think we intended to have a conversion of measurements here in this unit. But if we wanted to actually work with inches and millimeters, we'd be able to convert between the two and find the equivalent. But for the sake of really just emphasizing that we are working with just the line segment postulate. So that would be the result of subtracting the smaller segment that's given to us from the entire segment to find the missing segment GH. Okay, now let's change up the notation a little bit. So now this is in proof notation. They're providing us with what's called a given. So this is kind of the background information, and we have our prompt then, which is to find BC. So they are telling us that AB, segment AB is 4, segment CD is 13, and then the full segment AD is 21. We want to find BC. So this is a more advanced version of the line segment postulate. So we need to add up all of our pieces and say here that AB plus BC plus CD equals AD. So notice that the line segment postulate extends to cases other than just adding two different ones. If we know that we're solving for BC, then we need to go ahead and subtract both of the other line segments, AB and CD, to the right, so to get BC isolated. So if I go ahead and do this here, I'm going to have BC equals AD minus AB minus CD. So I've just subtracted them to the other side so that I have isolated my unknown. And now I can substitute my values in. So I see that BC equals AD, which is given to me as 21, minus AB, which is 4, minus CD, which is 13. I'm going to go ahead and simplify. So if I take 21 minus 4, that takes me to 17. 17 minus 13 would give me 4. So this missing segment is 4. I can always confirm by saying, well, does 4 plus 4, which is 8, plus 13 give me 21? Right, so if I do add those together, yes, in fact, they do add to 21. And now we're going to add some fractions into the mix. So here they're giving us, we have another, yes, here. QP is 4/18. NP is 2/3. Notice that the direction from which we're naming these line segments, it doesn't actually change anything. So we can name from left to right or right to left, and it will still be the same segment that we're referring to. And they're telling us that MQ, this entire length, is 1. We want to find MN, this piece here. So we're again going to set up our postulate and say that MN plus NP plus PQ equals the full length, which is MN. MQ. So sorry, guys. Okay, and then we know we're looking for MN, so we need to isolate MN by subtracting the other two. So I'll say that MN equals MQ minus NP, so I've subtracted that from the left, minus PQ. And so I have that my MN equals, now that I start substituting, MQ is given to me as 1, minus NP, which is given to me as 2/3, minus PQ, which is named QP, but in this case, they are interchangeable, so it's minus 4/18. Okay, so this is where we have to do some fraction math in the background here. If I'm subtracting these two guys, 1, I can adjust to 3/3, right? I always want to write my whole number as a fraction with a common denominator to the one that I'm trying to combine it with. So if I take 3 over 3 minus 2 over 3, this is giving me 1/3. And then this results in 1/3 minus 4/18, which I will have to adjust once again. So if I adjust 1/3 to be a fraction over 18, to go from 3 to 18, that's times 6. So 1 times 6 would give me 6. So I have 6 over 18 minus 4 over 18, which is 2 over 18, simplifying to 1/9. So all of that to say that mn over here is 1 over 9. And there we have it. Okay. Another little mini thing to discuss is congruence. So we say that two figures or measures are congruent if they have the same measure. So congruence, well, let's just say same measure for, in this context, two line segments. This is just another way of saying that the line segments are equal. So let's just say they are equal. When we talk about congruence statements has us equating our two line segments with a congruence symbol, which is a little equal sign with this curvy tilde on top. So this is the sign that equates my two line segments. And this says that, in this case, two line segments are congruent. Segments are congruent. And remember, because we just established that congruence means that they are equal, they have the same measure. So if two line segments are congruent, they have, or we'll say they are equal, or they have the same measure. So let's extend that to this example here. So if we are now given a diagram and we're told that EF, which is this length here, is congruent to FG, let's change our color here, is congruent, oh, I guess you can't highlight in that direction. Look like this. So EF is congruent to FG. Based on our understanding of congruence, if it's asking us to find FG, right? If I know that this is 6 and my yellow segment is congruent to my teal segment, they have to be the same. So FG is also 6. So we say that FG equals 6 because it is congruent to line segment EF, to EF. And there you have it, guys.